So basically, dimensionality reduction techniques must be employed to reduce the number of variables. The popular technique is principal component analysis. It does not delete variables, rather combine variables into components based on covariance matrix, and it ensures the converted data set has all the patterns and trends intact. No loss of information pattern is there. It compresses the data and also reduces the computational time and power, and it eliminates redundant features. Now, principal components. Principal components are linear combination of original variables and are orthogonal. Any idea what is this orthogonal? See, orthogonal is different axes. Typically, we have singular axis, right, in normal data, whereas in principal components, you have a rotatory axis. See, the axis orthogonal will have different axes. Rotation, 90-degree orthogonal axis. So this is the orthogonal axis. This is orthonormal. Both are 90 degrees. Okay. So this is what it will combine. Finally, the principal components are linear combination and are orthogonal. Not the same, almost same, but the formula is different. We'll talk about it. The first principal component accounts for most of the possible variation in the data. Most of the possible variation in data is accounted by the first component. Second principal component captures the variance in the data, captures the remaining variance in the data. So the PCA algorithm uses eigenvalues and eigenvectors. Eigenvalues and eigenvectors of the covariance matrix are used to create principal components. So eigenvalues and eigenvectors are used to create these principal components. All right. Now, let us understand this with a simple calculation which you can do, a two-dimensional calculation we can do. Whereas in our real-time data, it will be n-dimensional calculations, which is very difficult to understand. Now, I will show you how this whole thing works in an Excel sheet in a simplistic manner. So all of you can open an Excel sheet. So all of you can see this. Let us say I have different variables x1, x2, x3, x4, x5, and x6. We have these variables. X. You want me to increase the font? Okay. Enough? We have these variables x1, x2, x3, and I have two observations 2, 1, 3, 5, 4, 3, 5, 6, 6, 7, 7, 8. All of you can see this, right? Or you want me to increase the font further? All right. You have to calculate the mean vector. You have to calculate the mean vector represented by mu. We have to calculate the mean. So is equal to average of this row, and you drag the formula down. Okay, all of you calculated the average. Average, simple average of the row.
Yeah.
Average of the row. Okay. Now we will subtract the average. Subtract average from each of the values. We will subtract the mean from each of the values. That means is equal to 2 minus 4.5. The 4.5 being constant, we will plus F4, 2 minus 4.5, and you drag the formula to right, and this would be is equal to 1 minus 5. You have to fix the 5 because the mean is common, and you drag it to the right. So subtract mean from the values. I have subtracted the mean from the values. Relevant row mean, relevant row average. From each of the values. Okay, all of you got this? You have deducted the values from the rows. This is the formula. Individually you have to do, no? Mean is constant. Mean is same for all, but it has to replace, removed, deleted, subtracted from each of the values, row wise. Two minus 4.5, 3 minus 4.5, 4 minus 4.5, 5 minus 4.5, 6 minus 4.5, 7 minus 4.5. Similarly, 1 minus 5, 5 minus 5, 3 minus 5, 6 minus 5, 7 minus 5, and 8 minus 5. Got it, all of you? Yeah. Now we have to calculate covariance matrix. We have to calculate covariance. We have to calculate covariance of above data table. We have to calculate covariance of the above data table. So go to data tab, data analysis, you will see covariance, select the values. Then you have to tick mark rows. Make sure by default it will be columns, tick mark rows, and then output range, select some empty cells. Output range, select some empty cells and click OK. Okay, what is this thing? Covariance of the values. You select the values, then tick mark rows, output range, select some empty cells, click OK. Covariance, data analysis tool pack, covariance, and then input range, you select this data range. Click on this color box, select the data range, go back. By default, it will be columns, tick mark rows, change this. By default, it will be columns, make it rows. Click on output range, click on this color box and select some empty cells and click OK. Go to file options and add-ons. Excel options will be there, add-ons, add-ins. In that add-ins, manage Excel add-ins, go. Click on manage Excel add-ins, go. You will get the option, tick mark data analysis tool pack. All of you have the data analysis tool pack, right?
The output also the output range.
Output range, select some empty cells. No, don't select. You have the existing sheet only, output range, empty cells. File options. Got it, all of you? Shall I continue? Yeah. So the final covariance matrix is this. The covariance matrix is this. 2.92, I'm round it up, 2.92, 3.67, 3.67, and 5.67. This is the covariance matrix which we get finally from our data. 2.92, 3.67, 5.67. This diagonal value will be the same, repetitive value. So this is the final covariance matrix. I'm rounding off to 2.92, 3.67, 3.67, and 5.67. Okay. So once you have the covariance matrix, insert lambda. Why it is not inserting the symbol? Got it? So lambda is an eigenvalue. Lambda is an eigenvalue for a matrix M. Lambda is an eigenvalue for a matrix M if this characteristic equation is met. If this characteristic equation is met. So what is the characteristic equation? Matrix M minus lambda I, yes, minus lambda I equals to 0. This is the characteristic equation for calculating the lambda values. Matrix characteristic equation is M minus lambda I. What is I? Identity matrix. I is identity matrix. What is an identity matrix? 2 by 2, 1 0 0 1. Identity matrix means 1 0 0 1, 2 by 2. 2 by 2 matrix. Only the diagonal values are 1, the other values are 0. That is an identity matrix. So we need to solve this using this matrix equation. So based on this equation, the values are so we will multiply this with the matrix equation of lambda 0 0 lambda. So this is the other matrix, identity matrix. You need to multiply these two matrices. You have to multiply these two matrices. If you multiply these two matrices, what will you get? You have to multiply these two matrices. This M matrix, this is your M matrix, this is your lambda I matrix. This is your lambda I matrix. I multiplied lambda with identity matrix. You got lambda 0, 0, lambda. Lambda into 1, lambda into 1. Now we need to multiply these two. If you multiply these two, what you will get is 2.92 minus lambda into 5.67. 5.67 minus lambda minus 3.67 into 3.67. 3.67 into 3.67. Here also I'll put an into sign. Okay. Matrix multiplication. Row with column. Row with column. Now, if you simplify this, you will get it as the final simplification would be lambda square, lambda to the power of 2 minus 8.59 lambda plus 3.09 is equal to 0. Oh, I forgot is equal to 0 here. Is equal to 0. If you simplify the above equation, you will get lambda square minus 8.59x lambda, 8.59 lambda plus 3.9 is equal to 0. So how will you solve the quadratic equation? Plus or minus b into square root of what you call b square minus ac by 2a, b square minus 4ac by 2a. So based on that, we will get the lambda values as sorry. If you solve the above quadratic equation, lambda will be 8.22 comma 0.38. Solving the quadratic equation. Based on the solution to the quadratic equation, we got lambda is equal to 8.22 and 0.38. Now these are eigenvalues. These are eigenvalues. What we have calculated now, we call them as eigenvalues. These are your eigenvalues. These are your two eigenvalues. Right? Got it, all of you? Now we have to calculate eigenvector. We got the eigenvalues, we will calculate eigenvector. Now the formula for eigenvector is mx is equal to lambda x. M matrix x is equal to lambda x. This is the eigenvector formula. Mx is equal to lambda x, where M is the, what is M here? The covariance matrix. What is X here? X is your eigenvector. And then lambda is your, what is lambda? Eigenvalue. Eigenvalues are your lambda. Matrix X is equal to lambda X is your eigenvector formula. where M is your covariance matrix, X is your eigenvector, lambda is your eigenvalues. So in the eigenvalues, we will take the larger eigenvalue. We will remove the smaller eigenvalues. We can now safely delete the smaller eigenvalues because 8.22 is a very large eigenvalue, right? The second eigenvalue is not giving us much of the intent. So you will take only the larger eigenvalue. So based on this formula, what we will do is, what is our matrix X? 2.92, 2.92 and 3.67. This is 3.67 and this is our 5.67. This is our covariance matrix. This is our covariance matrix, right? Now you multiply with x1, x2 is equal to, what is the is equal to, will be equal to 8.22. We will take the largest eigenvalue, which is 8.22 multiplied by x1, x2. Multiplied by x1, x2. These two multiplied by these two. So if you solve this equation, you will get the values as 2.92 x1, 2.92 x1 plus 3.67 x2 is equal to 8.22 x1. Similarly, by multiplying the second row, we will also get 3.67 x1 plus 5.67 x2 is equal to 8.22 x2. Okay, this is the two equations we get from the solving the above two. Now, if you solve this further, 5.3 x1, 5.3 x1, because 8.2 come this side minus, na? Yes. Or you take 2.92 the other side. 5.3 x1 is equal to 3.67 x2. Below it is 3.67 x1 plus is equal to 2.55 x2. 2.55 x2. So based on this, x1 is equal to 0.69 x2. If you simplify this further, you will get as x1 is equal to 0.69 x2. If you simplify this 2 further, you will get this value. X1 is equal to 0.69 x2. 0.69. So x1 is how much? 2.55. X2 is 3.67. So the eigenvectors x1, x2 is equal to 2.55, sorry, 2.55, 3.67. So you can try 2.55. Sorry. X1 is equal to 3.67 into 0.69. 2.5323 or rounded off to 2.55. You'll get the same value. So the eigenvectors are these two. These are two are the vectors. So the principal components would be the PCA would be x1 2.55, x2 3.67. So we had a very large data, right? We had a very big data. This is our whole data. Now this whole data has been minimized to two components, 2.55 and 3.67. 2.55 and 3.67. So this is how the eigenvalues and eigenvectors are calculated. So we have reduced from 6 variables to 2 components. We have reduced it to, this is like comp1, component 1. This is component 2. Yeah, this is the same replication. You will get the opposite side, no? You get half matrix only, which is the replication of the other matrix, above matrix. So you'll get only half like this. So this is the whole process of how the PCA works using eigenvalues and eigenvectors. But in Python, it uses a different formula. Python is based on something called singular vector decomposition, SVD method. Actually, most of the softwares use this only. In Python also, we have this. We have eigenvalues and eigenvectors method also. But for faster computation, Python uses a method called singular value decomposition for faster computation. There is a marginal difference between these two, the eigenvalues and the eigenvectors, and the what we call it as singular value decomposition. Now, singular value decomposition so if you are looking PCA in Python, sklearn principal component analysis, decomposition PCA. So here, linear dimensionality reduction using singular value decomposition of the data. So Python uses by default singular value decomposition. What is this? Python uses singular value decomposition method for PCA, which is, the formula is little bit complicated. This is the formula. A is equal to U E V transpose. A belongs to R Mn, real or complex matrix. U belongs to M into M, real or complex unitary matrix. Then rectangular diagonal matrix. V is the complex unitary matrix. So this is the whole process it goes through. This is the formula for single value decomposition, where it uses this formula to calculate the decomposition values, because this is comparatively faster than your eigenvalues and eigenvector calculation. So singular value decomposition is a method used by Python for doing decomposition, SVD decomposition. So SVD decomposition so it is a little bit of complicated calculation, right? Why is Siri is on? Okay, so this is the methodology used by Python for singular value decomposition. So any doubts in Python, sorry, decomposition, eigenvalues, PCA? Got it, all of you? Now, let us run PCA on our data.
So sir, here by using SVT also we are creating an eigen.
SVD also will do a dimensional reduction only,
So
but it
that
uses
we are creating
components.
an component also.
Component 1 and 2 or whatever number of components you want, it will calculate.
But when compared to group process, it will make faster.
SVD is faster for large data sets. Okay. So now our data, let us look at the data, split data into Y and X. What is Y here? Y is equal to activity train dot activity. No,
You see the unsupervised.
yeah, it's unsupervised learning. You can use it for unsupervised learning also.
So now find out the like means unsupervised.
No. Wait. Don't jump. Let's go through the process. I'll answer that question. Why it is creating so much of problem? Activity train dot columns. The dependent variable is activity. Y is equal to activity train dot activity. X is equal to activity train dot drop square bracket single quote subject and the dependent variable activity comma axis is equal to 1. Now find out how many levels are there in Y. y dot value underscore counts. Basically, this is a multinomial data with 6 classes in Y. Okay, this is a multinomial data with 6 classes in Y. Laying, standing, sitting, walking, walking upstairs, and walking downstairs. So we have to predict this. But because our data is very high dimensional, we have to decompose. From sklearn dot decomposition, import PCA. From sklearn dot decomposition, import PCA. PCA is equal to PCA n underscore components. So we have 563 variables. I am randomly choosing a component as 280. This 280 is randomly chosen value. You have to give a randomly chosen value. So I am taking half of it. Okay, I am just giving half of the data as to be components. X underscore PCA is equal to PCA dot fit X. X underscore PCA is equal to PCA dot fit X. So I have fitted it on our independent variables. X underscore variance is equal to X underscore PCA dot explained variance ratio. Explained variance ratio. X underscore variance is equal to NP dot cumulative sum open bracket NP dot round open bracket X underscore variance comma decimals is equal to 4 into 100. So we are converting the variance, which will be a decimal value, into a proper value. PLT dot plot X underscore variance. Cumulative sum. All right, you can take your break. You have worked on the engagement score? Oh, what model you have used? Regression methods. Okay. Oh, very less. No, actually, you have to use collaborative filtering. We have not taught you, na? But in.
we got 0.53
Huh.
SPD model.
Single value decomposition.
Single value decomposition.
Why do you need to do SVD?
I don't know, sir. I have downloaded its file, sir.
Huh.
That's the
Because collaborative filtering is what we have to use. In collaborative filtering, you have to have only 3 columns: engagement score, what you call video ID, and user ID. That's all. User ID, video ID, and engagement score. Only these 3 columns we can use collaborative filtering, which is like recommendation engine, recommender system. I'll come there. But other independent variables are also there. We can do their use for exploratory data analysis.
This is the actual foundation.
Collaborative filtering, he has used. Someone, he has used collaborative filtering. SVD, matrix factorization. It is not SVD, it is matrix factorization. What is I think the recommender systems we have not taught. We have not taught about next concept. Recommendation systems are used by Netflix, Amazon, and all. So based on the user ratings, based on the user ID, UPID, and ratings, what can you recommend to the customer? The customer, I know it is a collaborative filtering problem. Regression models, user or discrete features that would not be important since they are very large. User ID is very large.
It's a 20.
That's what they have got. So,
Sir, we brought the category ID also.
but category ID you can keep now.
But he dropped this. Because when we did the suggestion, category ID is not
Was the recommended system problem. The other variables are needed only for exploratory data. You have to do ED on other variables, and then you have to do recommender system, collaborative filtering. I taught them in PySpark. Last class only, Spark, Apache Spark. I taught your BPA 17, still 17. Last Friday only I taught them. Collaborative filtering using Python Spark. You can do same collaborative filtering using Python also. Recommender systems. Call them as recommendation in our recommender system.
Sir, but
They are regression.
ordinal encoding.
Huh?
Patience.
But see, he said that it was right.
Yeah, it was.
So he has this one collaborative filtering. So how much is score he got? But no, you have checked today.
Yes, sir.
Because last minute people will submit.
Sir, yesterday night was the last.
Yeah, around 11 to 12, you will see a lot of submissions. I know it was a collaborative filtering only. I indicated it to the other guys. They were not able to understand. Because in PySpark, we do that. Python Spark, which is a large data set. Na? You heard about that movie lens data set. Movie lens data set is a very large data set. With movies metadata. Metadata means what is that movie, how much was the budget, what type of movie it is, genre, action, romantic, who is the actor, who is the actress, what was the review, all these details will be there. Recommender engine only Rupam has built. Yeah.
Any movie will post.
It will recommend the movies. Yes. Same. We call it as recommendation system. So last class only I taught them this movie lens data. See, the thing is they misguided you. No. This thing, whole thing is you got misguided because of the other independent variables. Because the other variables are needed only for exploratory data analysis. They ask you to do EDA, right? That is what is there. But if you are looking at typical collaborative filtering, what is it, collaborative filtering? I didn't upload it. It will not work. No improvement. So, Untitled one. This is the one. No? Because it requires Google Colab only. You can't run it.
And for SVM, we do 4 hours, but showing the parameters.
So we just assume.
So this is the one. I taught them last Friday only. Recommendation engine, demographic filtering, collaborative filtering. This is the one. User ID, movie ID, and rating. And then we use this methodology. We call this as rating matrix into they call SVD. Different type of SVD. So here it's a regression only. Iteration 5, user call is user, this thing. And once you fit it, you'll get predictions also. So once you get the predictions, you can give them whatever based on the user, you can give the prediction. So that the data is all about collaborative filtering only. So this is the one. Got it? So this is the one. So once you have done the model, you take any single user. So user ID 10. What are the recommended movies to him? Movie ID 588, 296, 593, 165, 590. He has given these ratings as 5, 5, 4, 4, 3. The predicted ratings are also, if you round them up, they are equal to this only, right? So, except this one, this is a mismatch. Because this will be taken as 4. This is only wrong, but otherwise everything is right. So, similarly, we have predicted the rating for different user IDs and also. So, this is called collaborative filtering using alternative least square method. It is a regression model only. So, on that data, any recommendations, you always do recommender system. We'll do it in Python also, let me see. Or we'll do it when I teach you PySpark. If I teach you PySpark or somebody maybe.
And how different from what is
Because this is purely based on IDs. User ID, you are not taking any other independent variable. No? There is a user ID, movie ID, and rating. The 3 columns only you will take. And it creates a singular value decomposition. The matrix, rating matrix is equal to what you call that weight matrix into ID matrix, item matrix. So that is a different thing. So for any recommendation, and there is one more called matrix factorization method. ALS using SVD method, ALS using matrix factorization method also is there. And in PySpark, in the latest version, they have added one more method, which is proposed by Netflix guys. So they are there. Yeah, please. So, pre-break, we have plotted see why we have done all this thing is, there is no fixed formula to find out how many components are the best possible components. So what we do is, we randomly take a number, fit a model, and then once we fit the model, we'll plot the variance into a scree plot. Now this plot is showing at some point it is becoming a straight line, right? The variance is becoming a straight line somewhere around this point, right? It is becoming a straight line, or the variance is becoming constant variance. Now using this plot, we can find out how many components exactly we can take. Typically, we want to take till that point of components where the variance is minimizing smaller or variance is becoming constant. Now, in this plot, if you see here around 150 to 200, it is becoming a straight line. Now, if you are not sure from the plot where exactly it is becoming a straight line, you can type the variance, and now you can check the values. Now, 99.75 is the constant point, right? From 99.75, the variance becoming a straight line. Now, if you look at the prior values also, the variance is becoming 0.2 or 0.3, which is a minimum change, which is a smaller change from very long. So if you look at this point, here it is 0.05 change. Now, let us say 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if you look at it from this point onwards, it's becoming 2. Marginal change, right? So I think 51, 54, 57, till this point we can take, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 into 9, how much? 135 components. 15 into 9 is 135 components. So we can take the point at which the variance is becoming minimal, or you can take the point where the variance is becoming constant. But we have a number of rows as 7,352. So if we take 135 components, it meets our criteria. Or if you want, you can add 5 more components, or we say we will take 140 components. 140 into 50 is 7,000. So it will meet our criteria. So based on this, we will finalize our model with number of components selected from the model. So I will take PCA is equal to PCA n underscore components is equal to 140. Okay, 140 into 50, 7,000. It will meet our observations. Till 140, the variance is, you can take even less also. Some people say wherever the variance is going down below 5%, that we will not take. So there is no threshold, but you need to decide where the variance is minimizing, or worst case scenario where it is becoming a constant value. Now, if you go to constant value, it goes up to 220 or something like that. But 220 into 50, we need 10,000 observations. So this is a judgmental call we have to take. So I am taking 140 as my components, and PCA underscore final is equal to PCA dot fit x. PCA underscore final is equal to PCA dot transform x. So we don't need dependent variable for running dimensionality reduction. But if you are using linear discriminant analysis as dimensionality reduction, you need dependent variable. Whereas in PCA, we don't need the dependent variable for doing dimensionality reduction. We only need independent variables. So PCA underscore final dot shape. So we have 7,352 rows, 140 components. These are 140 components, not variables. These are 140 components, not variables. The point at which variance is minimizing, or point at which variance becomes constant. Did you guys do any EDA on that data? Huh? You can upload it into GitHub. I'll tell you the model also. I'll upload. We can upload. And then you also mentioned that in the resume that you participated in hackathons. And what was the score or rank? Create a small section called hackathon section. You can show the code. Yeah. So I'll teach you the collaborative filtering. Some place after not project section. Project section you can mention it as a hackathon. Participated in hackathon and did the project. That you can show it there. Or some people put hackathon, if they have multiple hackathons, they put it as a separate section. Name of the hackathon, score and rank. Name of the hackathon, score and rank. We already have participated, right? Flu H1N1 we have done. That is a hackathon, right? No, even the time gone, we have participated. That is one thing. We also participated advanced house prices, Kaggle thing. That is a hackathon. You can mention your score and rank. Similarly, Black Friday, we have Black Friday sales, we have done that. HR analytics, we have done the hackathons. So you can give these hackathons your score and your rank as a separate box. See, even if you look at this thing, they were asking for GitHub link as well as Kaggle link. So I have taught you how to do it on Kaggle, right? So do a couple of things on Kaggle, same projects, repeat them in Kaggle also, and put the Kaggle link also. So what you do is advanced house price, you do it in Kaggle itself. Copy paste the code into Kaggle, run it, and give that Kaggle link also. Because they're asking two links, right? GitHub link and Kaggle link in that pre-registration. So you can give both GitHub and Kaggle link. See, these competitions help the PJ 17 days to crack interviews and practical knowledge. You have learned something, right? In this whole process of this thing, you checked your SQL is a bit weak. We'll work on SQL. And then ML, all of you are comfortable with. We know how to build models, how to clean data and all those things. Those processes will help you to get selected faster. And avoid all textbook data sets. Iris, O2, Titanic, empty cars, wine quality, all these things, diabetes, ignore them. Don't even think about them. Use practical hackathon projects. And EDA is must. Without doing EDA, don't jump into model. So when will you give your first mocks? This week or next week? Mock interviews. Mock interviews. Are covering all statistics, ML, Python, everything. All algorithms and statistics. Each student will be taken 20 to 30 minutes. So when will you give? This week or next week? We'll freeze the date. Next week, what day? Finalize. Friday. Prepare yourself completely with the concepts and all.
Overall Python and
Not Python. Python is only one part. Statistics, the descriptive statistics, hypothesis testing, regression models, classification models, then your what you call feature engineering, data pre-processing, all those methodologies. Then your concepts like what is bias, variance, underfitting, overfitting, and all these things. No time series. Deep learning. Deep learning we have not started, right? NLP is not there. ANN we have done. ANN questions might be asked. MLP. ANN as MLP. We have not done deep learning. Deep learning is a different thing. So all the models, you go through the theory, just read the PDF files which I sent, short theory notes, read them. Okay, your questions will be what is the p-value, what is its importance, what is overfitting versus underfitting, what are the assumptions of regression, what is confusion matrix, what is the formula for precision. I like how they ask in real-time interview, same process will be followed. And the mock will be recorded. It will be on Zoom. You will be sitting in that room. I'll sit in here and ask the questions. Face to face also, it's okay. It's up to, because most of them happen telephonic, right? That is why we are looking at a Zoom based thing.
There no like web scraping and
There, that will be a second mock later. NLP, time series, and deep learning will be your second mock. Before that, there will be a written test on those concepts. Like how you did that 50-mark test covering concepts, right? So we need to do another 50-mark test also. That I will do sometime this Friday or next time sometime, because that way you are only MCQ questions, right? On the remaining algorithms, SVM, PCA, all these things have to be covered. Na? Another 50-mark test will be there. And I will also try to punch in some SQL questions also into that. And then we'll do a MCQ test again for 50 marks. That same timer, 1 hour, all things. We'll do unsupervised learning. When I talked about K-means, na, because that's what supervised learning only. Both of them, when I talk about Euclidean distance, right? That time I will talk about it. So KNN and unsupervised learning I teach together, because both of them use Euclidean learning, the Euclidean distance. Both of them use Manhattan distance or Minkowski or Hamming or whatever it is. So that's why KNN, again, why to repeat the distance thing again? Same day, pre-break, we'll discuss KNN, post-break, I'll show the calculation also. How exactly it works, and also the calculation for K-means in Excel sheet. That will be done. So because it's a distance mechanism, right? Distance-based algorithms, we all talk in one go. That will be covered. Up to neural network, MLP, multi-layer perceptron. Okay, so just go through the notes which I have given in the things. If possible, listen to the videos also, then you can easily clear it off. Just like how we did it, things. 30 questions will be very easy, 20 questions will be difficult, like how we do the thing. Last time also same pattern I followed. 20 questions will be applicative or a little bit difficult in terms of this thing. The 30 will be easy one, everybody can answer those questions. Okay, now we have got our data into a proper shape. We have done the dimensionality reduction. We have done the data into proper shape. And please start applying whatever data science job you see apply. Whatever calls come, you take them. Answer, you enter into the interview process. If they send any data set to work, you please work on it. Start doing now. Because by the time these guys set up, you should at least have given 3 interviews as a practice to outside. See, I'll take mocks, but that is not as real as you apply for a job and then get it. So whatever internship, whatever you see, just apply. We have finalized your resumes, right? We have finalized all our resumes. Keep on applying for everything. Whatever call comes, attend it. Give the interview. You will know yourself, the real time. If they send data set, attend, give the, if you need any help, I'll help you out. We'll take the data set. If they send you a test link, do the test. By doing this, by the time you attend Wipro or Infosys or any other Capgemini here, you will be fully prepared to attend those interviews. That's what 17 guys are also did. Each person gave 3 to 4 interviews before they attended these interviews. Give everything, whatever you see data science, whether joining or nothing, you will not take into consideration. The agenda is have experience of interviewing, answering questions. Then you will know your weaknesses. Whether you are, see, the main problem I find is you know the concept, but you are not able to explain it in technical terms. You have to use the technical terms. That is the biggest problem. You all know the concept, but you should be able to explain it in a proper technical terms. So if you are talking about multiple linear regression, you should use the word linear relationship. You should use the word dependent variable. You should use the word independent variables. You should use the word multicollinearity. Right? We all know ML are very easily, but you have to use these technical words. Then only the interview guys will know whether you understand the concept clearly or not. Okay, so the way you explain, that is also very, very important. It happened with 17 couple of guys. They know the concept. They are comparatively better than the people who got selected. The reason why they failed interviews were they were not able to explain themselves clearly. Now, when they are able to explain, even though we tell the recruiter is a good guy, good thing, but they will not listen to us, right? So the reason why some of the PJ 17 guys could not get through was communication. They know the concept very well, but they were not able to explain it to the interviewer, which is nothing but a communication problem. So please overcome that and prepare yourself, right? So whatever comes, you apply. LinkedIn jobs, Naukri, keep on applying. You will get calls. If you apply with proper resume, with GitHub link and GitHub profiles and all, you will definitely get it. But does your resume has GitHub link and all properly done?
Yes, sir.
Then you replace your resume, delete your old resume, create a new resume with LinkedIn profile, and there is something called LinkedIn projects. Copy paste the same projects which you have in your resume in that LinkedIn projects. Okay. And also change your resume headline as data science aspirant with expertise in Python, R, and SQL. Data science aspirant. Don't use the word student. No, aspirant. You are not enthusiastic. Enthusiastic after getting the job. Before getting the job, it is aspirant. Your resume headline should be data science aspirant with expertise in Python, R, and SQL. Participated in multiple hackathons, if you want. If you want, you can say participated in multiple hackathons. Aspirant. With expertise in Python, R, SQL, and statistics. So please give interviews, then only you will understand what was the lacking skill. Now we will label encode our dependent variable. From sklearn dot preprocessing import label encoder. LE is equal to label encoder. Y is equal to LE dot fit underscore transform Y. See, once I changed the resume of PJ 17, they got number of interviews. You might see, right? Even today, they're getting calls. Once you have the resume properly done with projects, GitHub link, Kaggle link, and LinkedIn link with all those things, if you are properly written. Okay. I have given you that project summarizations, right? I have not given you the project summarization.
Interview questions also.
Interview questions I have not forwarded. I'll do that today.
Sample questions.
See here, this is the format I am forwarding. So, no, this format has the GitHub project. See, so your choice, whatever you want, you can do. Project, objective, process, and learning. Okay, let me download this and show you clearly. And on the right side, I have already given you the skills. Now, you need to add your certification badges. I told you to do certifications also, right? That IBM cognitive things and all badges. Just complete them. They're completion only. You don't need to write any test or anything. Badge will come. No name will come. You just need to put the badge there. That's all. In your LinkedIn profile, you attach it. That's all. You can attach the badge to your LinkedIn profile. And you see here certifications, badges, and skill tests you have done. You can write it. Key skills I have listed down. descriptive data visualization, hypothesis testing, etc. Machine learning, data pre-processing and all we have to do. See IoT, NLP, image processing, Apache Spark, PySpark, that you remove. These things you can remove. Okay, later you can add. But these are the three projects which I think will give you more weightage, or you can replace them with any other of your project, your choice. But the project should have these things: project title, objective, process, and learning.
Top 3 or 4 projects.
3 projects max. And
Accuracy equal to the criteria.
you have to mention the accuracies there. In the brackets, the accuracies in the case of top one, F1, recall score, imbalance. See, this is an imbalanced problem. This is a balanced problem, which is interesting, right? Which will give you higher chance of recruitment than other people. Because you are learning imbalance also, which most people don't learn. So imbalance and balance, comparative analysis. And then house price prediction is a regression problem, which you are very familiar with. You can write the R square and RMSE in the brackets I mentioned, right? And based on this, you filter these things based on this. If you are good in data visualization and all, you can add the software, Power BI or Tableau or whatever it is. You have to add SQL here. I didn't add SQL, but if you are good in SQL, DDL, DML, all those things are there, no? You write them as SQL. So SQL should follow here. So SQL should follow after your statistics. Okay. This I just forwarded to you. You can do this. Whichever you are confident. So the blue thing should have only those concepts which you are comfortable with. Remove all those things which you are not comfortable with from the blue skill section, and add whatever you are comfortable with. Now, to replace that, you should also have this certification badges and skills. Because in the recently MathWorks came here, they were asking for certifications also. Did you do any other certification? See, there are 2 types of certification: completion certifications, certified certification. Certified certification, you need to write the test. If you have completion certification also, that is enough. Not that you have to write 4,000. That cost is also very simple, 4,000 rupees. You can give multiple attempts or complete the course, and you write it as completed this course. You will get a mail. You can show them that I have completed this course. I know this concept very well. Okay, your education skills here, followed by your GitHub projects. And if you have any job experience, you first talk about experience and then education. Anybody has job experience here? No. So experience, education, and GitHub projects. No, any experience, any IT experiences, they are accepting. Any IT experience. Okay, so I've already forwarded this. You can look at this way and then convert this into a PDF file. Whenever you send something, convert it into PDF file and update. Upload it in LinkedIn Jobs, Naukri. Apply. That's all. Let them come back to you. Intentionally. Apply. Whatever comes, you take it. Joining or doing is secondary question. Primary is we want experience of interviews. Am I able to answer the questions clearly? Are my concepts clear? If you have any problem, you come to me. I'll help you out with those concepts clarity. Simple thing, right? Short notes, bullet points, sitting on a piece of paper and read them. That's all. Simple. And if I'm you, I will use every day from now to do one certification. There are 8 hours, 9 hours videos, right? 12-hour videos are there. Badges and all. They're very short, right? Cognitive classes. Do them. If you know the concept, let it run. If you don't know the concept, focus on it. Most of it is what I taught only, right? And LinkedIn assessment test. The skill test, I'm talking about the LinkedIn assessment test. You know, right? LinkedIn assessment test. I think only 2 attempts are there, or only 1 attempt. 2 attempts are there, right? LinkedIn assessment test. LinkedIn assessment test for Python, LinkedIn assessment for data science. You complete them. Once you complete the assessment test, you will get a certificate to your LinkedIn profile, and you can also list that skill test here. The skill test I am talking here is LinkedIn skill test. You know, right? LinkedIn assessment tests are there, skill tests are there for every part of data science they have. So please complete them as soon as possible. If you are not able to focus in your hostels or anything, you can have lunch, come back here, choose one room, sit together and do it. Sit together and do it now, if you can. That would be better. Sit here. Some room will be, post-lunch rooms are vacant. No, not well. The first room will be anyway vacant. You can sit here. I'll tell them they're doing some certifications and all. They'll allow you, no problem. And all sit together, complete it fast. Then only you'll complete it fast. Otherwise, individually, you will not be able to do it. So target them and finish them off, okay? Because if you have this, you'll definitely get calls. If you have LinkedIn assessment skill tests done, you will definitely get calls. Got it, all of you? So make sure I am pushing you because very soon you will be getting into that interview process. Maybe by end of this month or beginning next month, you will be having your interviews. I don't want to miss any single chance because once you lose the opportunity, you will not get it back after 9 months or 12 months. You know the company policies, right? So please make sure you complete those things very clearly. And Capgemini is offering less pay, but they are offering data science profiles. Your exit option would be very good. You will learn one skill. After 1 year, if you go out to market, your salary will double. And if you have multiple certifications, it might even triple also. Because Capgemini is building the skill on big data. PySpark, which Apache PySpark, they ask them to do certifications. They're putting money on it. They're building a skill set. And if you do 2 projects, you will be ready for the industry next 1 year or a year. You can get out and you can join any company with higher package. Okay. So they're all there. Wipro will come, Capgemini will come, Infosys will come. Infosys you all have applied, right? Or yet to apply? No, not for your batch. I think for the other batch, they have done Infosys. Which one? No, they say 2 years of experience, but training guys also they will take. I was there on that call.
They told on that meeting, but they didn't allow any.
No, they will do a different process. Professions. See, once they don't find people in 2 years experience, what will they have to do? Right? They have to go down, right? So they're taking a game, they're taking a chance. Okay, if doesn't have, maybe 1 month later, they'll come back to you guys. Trained people only they have to depend on. So it's the same game. I'm telling you, the market needs data science people, but there are not enough people who are good quality, who are good in theoretical statistics and things, which I am taking you through. Agreed or not? Every calculation, every statistics, we are taking. Not that you have to remember all of them. You choose 2 or 3 concepts, perfectly remember. That's all I wanted to do. Choose your own 3 concepts: regression, decision tree, random. No, not random, sorry. Support vector machine or KNN. KNN. Regression means both multiple binary, decision tree, and KNN. Simple. Just complete in and out, learn these things, you'll have. If you want to an advantage, learn neural networks or ensemble methods. Okay, forward it and please complete your LinkedIn skill tests and some badges. Because the ones that 17 guys did those things, they were getting calls. All those people who got into Capgemini, they have done LinkedIn assessment test as well as badges. And Santosh, I think he has joined which company? EXL Bangalore. Huh? Santosh is also there. He joined at 9 lakhs package or something. He has done multiple assessments, multiple this thing. He worked on, he even completed a deep learning certification and badge also. He is now in Bangalore working with someone. He got job on his own, not on this case. Okay. So please do all those things. And if you have any doubts in this, you can always reach out to me. But your resume should be ready. Start applying as soon as possible. Whether you get call or not, secondary. But if you get a call, take it, answer questions, evaluate. Okay. So we have label encoded our Y also.
when we get the components to it's like even like
Array. See now, type of, if you get it out, type na array. Like I told you now, whatever you do in Python, output will be an array. Any simple computation or any complicated computation you do in Python, the output will be an array. How do you convert an array into data frame? pd.data frame. That's all. Frankly speaking, in the LinkedIn assessment test, you guys have got how much? You got 21 or something, na? Link that AV analytics with the skill test. You got 18. Other people, almost somebody got 21 or 22 or something, right? 23. The other batches didn't even get 15. I'm talking about the DSP batch, working professional batch. They didn't. The maximum score was 14.
I attended for second test, second attempt, but same 18 only.
Yeah. Maybe that is the best score. So I have asked them to, the DSP guys have taken all the SQL photographs. Did anybody take any SQL photographs, SQL questions photographs? No, right? Because that while doing the DSP fellows, one guy has sent me the questions photograph. Yes. The SQL questions, na? So this guy has completely taken every question photograph for future preparation and all. So even if you guys, when you're giving the test, you take the photograph. If you don't need to activate the camera and all, so that you can refer to them later. See, their functions, code and all. So we will also give next month hackathon also. Again, there will be another hackathon in March 2nd week. And Hacker Earth also. Do you guys tackling Hacker Earth? Hacker Earth also has jobathons. Hackerearth.com. Just look at that also. Hacker Earth, driven data, your analytics vidya. These are all places where you will see jobathons happening. Hacker Earth has all Java, C, what you call .NET, all HTML will be there. Along with that, data science also will happen. Okay, all of you have label encoded the dependent variable. Now, from sklearn dot linear underscore model, import logistic regression. We'll build the logistic regression. Okay, logit is equal to logistic regression, multi-class is equal to multinomial. Otherwise, by default, it will do binary. So you have to add this argument and then build the model.
Severi.
Hmm?
Severi.
You attended, huh?
No. Pranay and Saturday.
So what did they ask? SQL, na? CBLE?
Yes.
You could answer. So SQL we have to do, even I have to do, because I didn't teach SQL in the last 2 years. I'm also finding those questions very difficult. So I'm planning to work on SQL data. We'll practice SQL also.
So you did the same process.
No, same fit, dot fit, dot score.
You have to give next iteration.
Now give max iterations as well, 3,000. 3,000 or 5,000 you can give. Okay. Print the confusion matrix also. So logit model is equal to logit dot fit x comma y dot score x comma y. So we have to add iterations. 3,000 were enough? No, minimum we can give 3,000. Logit model score is 99.25. Now test set also you have to convert it into this thing, right? So what not label encoding. So activity test is equal to, we have not imported, right? pd dot read underscore csv test dot csv. Okay. Then test underscore pca is equal to, what was the transform command we have given? pca dot transform. PCA dot transform activity test. Oh, sorry. We have to drop the subjective activity and subject. We have to drop it. So test data also has subject, what you call subject and activity. So activity test is equal to activity test dot drop square bracket single quote subject comma single quote activity comma axis is equal to 1. Then we have done the test PCA. We just need to run the transform function test underscore PCA dot shape. We have 2947 with 140 observations. So logit test predict is equal to logit model dot predict test underscore PCA. Oh shit, I made a mistake here. Score should be a separate function. Fit we can add it to here. Score must be separate function. Comma y. Okay. Now logit model dot predict test PCA. Oh, sorry. We have to give PC underscore final, yeah. See, PC underscore final is our X, right? That is the problem. Why yeah, maybe PC underscore final is our final X. 98.93. So logic test predict. Dot cross tab activity test dot activity comma logic test predict. We'll change the name here. Test. Then this will be test data. But the predict cross tab, only the diagonal ones are correct. You can predict the test predict activity. Dot activity. So what is the test accuracy got? Hmm.
There is a roster.
Hmm.
Just to drop that at active column.
That's why I renamed it, na? But we need that dependent variable column to calculate the accuracy, right? That's why I named it as test data. Now the accuracy is 537 plus 428 plus 512 plus 493 plus 401 plus 442 divided by open bracket. You can copy paste all of them again. Control C, Control V plus 60 plus 20 plus 4 plus 3 plus 3 plus 15 plus 27 plus 2. 95.45 accuracy. The sum total should be equal to 2947, right? So, yeah, 2947. Yes, correct. Only the diagonals are correct prediction. Rest of all are wrong predictions. What is out of diagonal, they're all wrong predictions. This is the process of running on test data. On train data, we got 98.93. On test data, we got 95.94.
Just scroll
Upper.
down.
Monday. You are done, do the decision tree. Hmm. Which accuracy score? You are saying metrics. On sklearn dot metrics import classification report. When classification report activity test dot activity comma, what is the other one? Logic test predict. Books of label input type string and number. Oh, we have to label and code test activity. Got it? You have to label and code test activity, then only it will take. So see here it is taking as laying and all, sitting and all. So that's what you have to do is you have to label and code. So activity test dot activity is equal to le dot, we have already imported, right? Le dot fit underscore transform activity test dot activity. And you do it, you get it here. See.
Next data we only perform transform. We did not perform fit, right?
Transform only, you will convert the data. Fit is not, fit is on the original, fit is the function fitting. Transform will do it, na? PCA is what? Fit function, right?
Fit underscore performance equal to
Fit underscore transform both. Here I separated fit and transform because we have to employ it on test data also, right? That's why I run fit separately, transform separately. Sometimes you have to do like that. Fit has to be run separately, transform as separately. But you can run fit underscore transform in one command also. I think fit underscore transform will also work.
So then it is not good.
Then if it is not working, then you have to separate fit and transform, two different functions.
But sir, here we don't need to fit, right?
We have fit now. PCA is what? PCA is what?
For test data.
Test data only transformation because the function is already fitted, right? The function is already fitted. Why would you fit it on it? We are just transforming the data according to the fitted function.
Activity test dot activity.
Huh.
Le dot fit underscore transform to get that.
Huh. For label encoding, you have to use fit underscore transform. For label encoding, you should use fit underscore transform. See, for some functions like dimensionality reduction, you can just run transform. Like how we do predict, na? Here transform is there.
Yesterday I got the same problem.
Hmm.
In December, we just need to transform the data.
Yeah,
We don't need to
fit it, yeah.
But when I did transform,
Hmm.
it takes.
That means you have done fit underscore transform
Yeah.
together in top. Then you have to separate those two functions, rerun them, and then run the transform again.
But the test data also got fitted.
Yeah. No, the function you have to see, the transform is to apply the function on data.
Yeah.
Fit is just defining the function.
Yes, sir. Just calculating in the
Fit is defining the function. Transform is conversion of the data into the function. So,
we will see.
so transform is where you want to change the data. So that's why I ran transform. I don't want to do fit the function again. I want to use already fitted function to transform my test data into the same parameters that was defined in the train model.
So now in test data, we can do fit underscore transform, right?
You can do try fit underscore transform.
There is no problem without fit or.
Print shape, na? You print shape, you will know. You should get 140 components. That's all.
We check that the same set. But 2947 comma not saying anything that columns, that components.
When you are using what,
Fit underscore transform.
then you have to do is only transform. You can't do fit underscore.
Only transform it is not happening.
Separate the top function, fit and transform separately first.
Is showing loop function is not supported for the input types.
So you have to separate it. Go to the top and separate it, fit and separate. You done it? Separate fit and separate transform, like how I run here. For PCA, you should fit and transform separately. See here.
Transfer is working, but after the transfer also it is showing like this one. And the column is not there. So we need a transfer.
You might have deleted it, na? Re-import the data again. Earlier you deleted it, you have to re-import the data again. Hello. third floor reception में दे दो. Hello? Hello? You're working on? See, Santosh has joined EXL as data science scientist. PJ 17. EXL is recruiting. I only sent yesterday. You want, I can send EXL also. You want to try EXL, but it is looking for interview, what you call experience. So EXL is doing this. EXL and this Bangalore and Gurgaon. Analytics experience of at least 2 years, must have working knowledge of SQL, Hive or Python, must have experience in data processing, time series, modeling packages and frameworks, must have worked on one or more modeling with GBM, regression, decision tree, random forest, k-means, clustering, etc. Familiarity with Hadoop and other big data platform can join us within next 2 to 4. He is the guy he is recruiting. I think Santosh has given experience. He has given some experience for 2 or 3 years and then he joined. Okay, you are on decision tree. Data classifier.
what?
More fitting. Next step.
कितना? Lengthy. Lengthy.